Hello there. How many people in the audience, if they could, would like to change some of the genes their parents had given them? Okay, I think that's the majority of you. Well, in the next few minutes, just let's see if that's going to be in any way feasible in the future. It's southern Iran. It's a dusty summer's day, and two black coffins are being carried behind a group of weeping mourners. And in those two identical black coffins are two identical twins, aged 32 years old, Laden and Lale. And as you can see, they were extremely close, conjoined twins. They'd spent all their lives together, and they had identical genes, identical DNA in every cell of their body, and they clearly had the same environment throughout all of their lives. And yet, despite that, there were certain important differences between them. One was more optimistic, outgoing, and religious, and the other was shy and preferred computer games to reading. One wanted to be a lawyer, the other a journalist. In fact, they so wanted to be different and independent, they were prepared to die for it. And that's exactly what happened when an operation to separate them that took 50 hours and many surgeons tragically failed. So how, with our current knowledge, can we explain these differences? For the last 20 years, I've been studying twins and have believed in the power of the gene. And I've been trying to convince a somewhat skeptical public and my colleagues of the importance of genes in behaviors and health. But 3 years ago, I changed my mind. And this is after studying twins, identical twins, and I decided to get together a large research grant and a project, and I also decided to write a book about the subject. And it's all about how you can change your genes, a bit like you can change a light switch. Identical twins, as we all know, look very similar. Now, they're formed when one single egg at 3 days old is split into two. And at that particular point, they are genetic clones of each other. They have the identical DNA and identical genes. And for the most part, they have very similar environments. Therefore, it's not surprising they look similar, they have the similar mannerisms, the same smiles when you take their picture, which the media love. But if you scratch beneath that superficial surface, you often find more differences than you might expect, particularly in personality and behavior. And what's also unappreciated and a bit odd is that identical twins rarely die of the same diseases. And they rarely get the same common diseases, even if those diseases are highly heritable, highly genetic. Examples include diabetes, schizophrenia, heart disease, arthritis. How can this be? These facts and the extraordinary isolated examples like the Iranian twins made me change my gene-centric view of the world and thought there must be something else going on. Now, there used to just be two elements, nature and nurture, black and white. But there's a third element, which we're going to call epigenetics, and the Greeks called it, well, they didn't actually call it, someone's used the Greek for the word, which means on or above the gene. And this is essentially the light switch, or more like the dimmer switch we've been referring to. What it means in English is a mechanism by which you can modify your genes which acts through successive generations in a reversible way using these chemical switches. Now, this can happen theoretically any time in life, but we now know that humans are particularly sensitive as a fetus in the neonatal stage and at puberty. And there are many examples I could use to describe this, from autism to sexuality, but let's use one example, perhaps which we can all relate to: body size and diet. Now, our propensity to putting on weight, being a bit chubby, or being very skinny, we all know is in part due to our genes and in part due to our environment. But what we haven't really appreciated until now is that our environment can act on our genes epigenetically. So the two are no longer as distinct as what we believed. Experiments of pregnant mothers have shown that when they're taking excess amounts of vitamins or excess amounts of alcohol, they can actually change their risk of producing chubby blonde children or chubby blonde grandchildren compared to skinny brunettes. And these chubby blondes are more likely to get diabetes than the brunettes. The fact that these are identical mice doesn't destroy the point, because the same things happen in humans. And there's evidence from human historical famines that epigenetically these changes can cross generations. And it's quite possible that the obesity epidemic that's facing the West at the moment is in part explained by events such as the major famines that came after the American Civil War in the United States, in the southern United States, which lasted for several years and is still having a knock-on effect with those chemical signals. And similarly, in Europe, at the beginning of the 20th century, the major stresses to those societies with famines, disease, wars, etc., could have occurred the same effects. And there are examples such as the Chinese famines and the Dutch hunger winter. But what about our mother's pregnancy? Could that have, and her diet during that time, could that have affected our genes? Most pregnant mothers nowadays take some form of supplements. Most take folic acid, for example, which is great for reducing birth defects such as spina bifida or a cleft palate. But what is less well known is that it also, in large amounts, can have minor effects on thousands of our genes, switching them off in ways we don't yet fully understand, but we know it's epigenetic. Even more worrying are other unwanted toxins that can appear in our bloodstream, such as those that come from plastics. And there's one in particular that works epigenetically. It's called bisphenol, or BPA, a product that's in most plastics and has been banned in Canada, but not in this country or the US. And this has been shown in animal studies to work epigenetically, affecting our hormone levels and also our brain neurochemicals, altering our behavior. And again, this can last through several generations when tested in animals. And it's quite difficult, particularly if you're a baby, to avoid plastic. And it's also difficult if you're trying to be healthy and avoiding spa waters, for example, which are pushed on us every day. But who else can we blame for these recent changes in our body weight? Could we blame prehistoric bugs, perhaps, that have been with us for 6 million years since we diverged from apes? Little known to us, we're carrying around 100 trillion of these little microbes in our guts, making up about 1 to 2 kilos of extra weight. No wonder it's called the forgotten organ. And in there are over 50,000 species, and perhaps more importantly, 20 times more genes than we have in our own bodies. And far from being dull, boring passengers sitting in the dark for long periods of time in our poo, they are actually having an important effect on our lives. we're all quite unique in this, and all of you share only about 40% of your gut bacteria with the person sitting next to you. Don't test it now, maybe wait till the break. But extraordinarily, even identical twins only share about 50%. And our individual makeup of our gut microbes are actually important in health as well. For example, certain types of microbes are associated with you putting on weight more easily, and others staying skinny. Other types of microbes are associated with our risk of allergies and immune diseases. And it's quite possible the recent changes that we've had in our immune systems and these increasing incidence of these diseases is due to our changes in our gut flora, which are probably due to our more narrow diets and increased use of antibiotics. Other studies have shown that these bacteria are associated with strange things like raised blood pressure and cancers of the colon and even autism. So ignore these at our peril. Now, some people who are trying to say, I want to change my gut flora, and these brave pioneers are taking part in what we doctors technically call a poo transplant. In it, they take someone else's super poo, who they think is extremely healthy, and they put it in a Magimix and dilute it down a bit, and actually put it into their own guts through their nose or through their bottom. The details are on the internet if those of you are... There is a do-it-yourself thing on YouTube. There's probably another TED talk on it. But for those of you who are a bit more squeamish, and I see a few of them, perhaps you ought to just stick to yogurts. But the important thing is these are very important, and they're going to be increasingly important in our health. And we're currently sifting through the poo of 6,000 of our twins for these bacteria, and it's proving to be a real treasure trove. But epigenetics is not just about wacky stuff. It's already saving lives. And I interviewed this pair of twins, and 4 years ago, Kristen and her sister were given a virtual death sentence. Kristen was diagnosed as having advanced breast cancer at the age of 23. Now, she's still alive, luckily, and the fact that her identical twin sister with the identical genes has only a 1 in 3 chance of also getting that cancer is down to epigenetics. Cancer cells and cancer, the tumour, work very cleverly by switching off our own natural body defences. They switch off our protective genes. And they do this epigenetically. And this allows the tumour to spread, etc., and eventually we die of it. But we're fighting back. And actually, there are now 4 epigenetic drugs on the market to fight cancers like leukemia. And they do this by reversing that process, switching back on that natural cancer protective gene that we all have. And there are at least 40 other drugs in development, not just for cancer, but also for diseases that you perhaps wouldn't have associated, such as fighting dementia and even trying to reverse the hunger hormone genes. These drugs are going to be very commonplace in the future. But what does the future hold for epigenetics? I hope I've shown you that there is, by studying identical twins, although genes are important, they're certainly not our destiny. And if you needed more convincing, if you were like the disappointed owner of CC, the cloned cat, the little kitten, disappointed to see that despite having the identical genes and DNA, the cat fur was really quite different due to epigenetics, you'd also see the point. But I see that our futures are not going to be like in the 1990s classic sci-fi film Gattaca, where everybody's DNA was taken at birth and their futures determined because of genetic sequencing, in the future we'll be taking blood samples successively from you to look at how your genes are changing and being modified both by our lifestyles and environment, vitamins and drugs, until we get that perfect blend to make us to live happily forever. But we're not quite there yet, as you can imagine. So what can you do now epigenetically for yourselves or your children? Well, the first thing you can do is exercise 3 times a day. This has been shown epigenetically to reverse the number 1 obesity gene, FTO, which works epigenetically on the brain. Also, by changing your diet, making it particularly more diverse, you can change your gut flora after a few months, and those gut flora will actually influence your own immune genes. They'll switch them epigenetically. You can avoid nasty toxins, not just plastics, but other household products like varnish and paints. One very good reason to avoid doing DIY. Also, cuddle your children a bit more, because that will epigenetically change their genes and make them more empathetic when you're older and need them. But the thing we mustn't forget is that underestimating the effect of willpower. Willpower is an important factor. We know that genes can affect willpower. We all have different susceptibility to willpower, but we also now believe that willpower itself could have the power to epigenetically modify our genes and therefore our destinies. Coming back to our twins, our identical twins, we've seen that they differ in subtle ways, and they can differ in terms of depression, in terms of sexuality, in terms of diseases like diabetes, in terms of promiscuity, criminal behavior, altruism, whatever you like. And in all those cases, epigenetics is the likely culprit. And in many of those cases, I've found a turning point in those twins' lives. For example, one pair of twins had a major family stress when they were younger. One reacted by overeating, comfort eating, and the other by going anorectic. And from that point on, their lives diverged and their genes diverged. So it looks as if evolution has given us this marvelous protective mechanism that when faced with some stress like wars, famines, disease, our genes will be subtly changed over the next few generations in unpredictable ways until those stresses and strains have disappeared, which seems a marvelous protective strategy. But I hope I've shown you that, to sum up, that we and our genes are perhaps more flexible and individual than you might have imagined, and that we are all, in our own way, and thankfully, identically different. Thank you.